Hello everyone, today we'll be solving linear equations with the distributive property. So before we get into actually solving linear equations this way, I want to give a short definition of what the distributive property actually is. And it basically means multiplication over addition or subtraction. So it means that when we multiply the sum or the difference of two or more numbers with a factor, we'll get a result that is the same as multiplying each number individually with the factor and then adding and subtracting the products together. So that was a lot to say in one sentence. So I do want to give an example to explain what I mean. So let me draw a line here. And let's say we have 4 and then in parentheses 1 plus 3. And we have to solve this. So there are two ways we can go about this in according to the distributive property. So one way we can do this is to find the sum of the two numbers in the parentheses, and whatever sum we get, we multiply by the factor outside the parentheses. So we can say 4, and then we have this sum in the parentheses, 1 plus 3. And if we solve that, we know that 1 plus 3 is equals to 4, so we can say 4 in the parentheses. And parentheses in math, it basically means multiplication. So multiplication, whenever you see a parentheses, you know you have to multiply the terms. So we have 4, and then we have 4 in parentheses. So basically, this is basically saying 4 times 4. And 4 times 4 is equals to 16. So that's one way of solving this problem by taking the sum in the brackets in the parentheses and then multiplying it by the number outside the parentheses, which was 4 in this case. So another way we can do this is by taking each number in the parentheses and individually multiplying it by the number outside the parentheses. And this is what we mean by the distributive property. So let's use a different color and rewrite this equation on the right-hand side. So we have 4 multiplied by 1 plus 3 in parentheses. So instead of taking the sum of 1 plus 3, instead we can take 4 and multiply each term individually. So 4 will multiply 1 first because it's the first term in the parentheses, and then 4 will multiply the second term, which is 3 in this case. So when that happens, we say 4. It multiplies 1 first, so we can say 4 times 1, and then plus, and then 4 multiplies the second term 3, so we say in another parentheses 4 times 3. So this is what the distributive property entails. We can either take the sum of two terms are multiplied by the number outside, or in this case, we can take each term individually and then multiply them. So now we have two products in parentheses. So if we solve this, we simplify this, we have 4 times 1, which is equals to 4, and then plus 4 times 3 is equals to 12. So now we have two products, which we just simplified, and now we can add these two products together. So 4 plus 12, excuse me, is equals to 16. And we can see that this is the same result as we got on the left-hand side here. So this is just what the distributive property is. Just multiplying the sum of or difference of two or more numbers with a factor that will give us the same result as multiplying each number individually with a factor. So now that we have basic understanding of what the distributive property is, let's try and use it to solve some linear equations. So let's get a new slide. So let's say 3 in parentheses 2x minus 4 is equals to 18. So again, since we're solving linear equations, we're here to solve the variable of this equation, and that's x, because x is the unknown value that we don't know the value of yet. So we have this term, this expression in parentheses, 2x minus 4. And we have a number outside of those parentheses, which is the number 3. So by using the distributive property, we can multiply 3 by the terms in the parentheses. So we can take 3 and multiply the two terms in this parentheses. So let's try and solve that. So we can say 3, and 2x is the first term in this parenthesis. So we can say 3 times 2x, and then minus, because minus follows afterwards. And then 3 will now multiply the second term in the parentheses. So we can say 3 times 4. And the whole of this is equals to 18. So let's simplify this. 3 times 2x, if we work that out, that's equals to 6x. And then minus, we have 3 times 4, and 3 times 4 is equals to 12. So 6x minus 12 is equals to 18. And now we have an equation. So this is a linear equation with a variable on one side. So now we can go about solving this as we normally would. We would have the variables on one side of the equation and move the constants to the other side of the equation. So in this case, our variable is x with a coefficient of 6. So that will be on the left-hand side of the equation. And then we have negative 12. We want negative 12 to be on this side. So since it's a negative number and it goes over the equals to sign, it becomes plus 12. And we can cross out negative 12 on this side. So now we're left with 6x, and 6x is equals to 18 plus 12. So 6x is equals to 18 plus 12 is equals to 30. So now we know the value of 6x, so now we can simplify to find the value of x. So to do that, we can divide both sides by 6. So 6 crosses out 6 on this. We're left with x, and x is equals to 30 divided by 6, and that's equals to 5. So this is our answer. X is equals to 5. So if you want, you can do a quick check. You can take the value of x and plug it into the former equation to see if we got the right thing. I'll do that really quickly just to make sure we solve the equation correctly. So we have 3, 2x minus 4 is equals to 18. So now we know the value of x is equals to 5, so we can plug it in to this equation. So we can say 3, and then x is equals to 5, so we can have it in parentheses here. Minus 4 is equals to 18. So we can say 3, and 2 times 5, so 2 with 5 in parentheses just basically means 2 times 5, and that's equals to 10. And 10 minus 4 is equals to 18. So here we have another example of the distributive property. So we can either take the sum, or in this case, the difference of 10 minus 4, and then whatever the difference is, we multiply by 3, or we can take 10 and 4 individually and multiply both by 3, but we'll still get the same answer. So to save some time, I will do it the first way. So we can say 3, and then 10 minus 4 is equals to 6, and that is equals to 18. So 3 times 6, that's 18, and 18 is equals to 18. And this is most definitely true. So we can also try and take the terms individually. We can take 3 multiplied by 10, that will give us 30, and 3 multiplied by 4 is equals to 12, and 30 minus 12 is also equals to 18. So that's just another way of solving it according to the distributive property. So let us go about solving another example. Okay, so let's say for, in parentheses, we have 2x plus 3 is equals to 28. So again, we have a variable that we have to solve for. We have x. We have to find the value of x. And we have this term or expression 2x plus 3 in parentheses. So what we can do is take the number outside the parentheses and multiply both terms in the parentheses. So we can say 4. 4 is the number outside the parentheses. And 4 multiplies the first term, which is 2x. So we have 4 times 2x. And then we have a plus. We write down the plus. And then 4 multiplies the second term in the parentheses, which is 3. So we have 4 times 3. And this whole equation is equals to 28. So we can simplify 4 times 2x, that's equals to 8, and x plus 4 times 3, that's equals to 12, and this is equals to 28. So now we have a linear expression with only a variable on one side. So now we can solve for x by moving the variables to one side and the constants to the other side. So we have 8x, and 12 is our constant. We have 112 on this side. And since 12 is a positive number, it has a plus in front of it. When a positive number goes over the equals to sign, it becomes negative 12. We can cross this out and say that 8x is equals to 28 minus 12. Okay, so 8x is equals to 28 minus 12 is equals to 16. So now we can solve for x. So we can divide both sides by 8. So 8 crosses out 8 on this side. We're left with x. So x is equals to 16 divided by 8 is equals to 2. So x is equals to 2. That is our answer. So let's check really quickly to see if we got the correct answer. And the former equation was 4, hold on. Let's write it out. So 4, 2x plus 3 equals to 28. This is our former equation. So let's plug in x equals to 2 into this equation. So 4, and we have 2. X is equals to 2, so we say 2 in parentheses 2 plus 3 is equals to 28. So simplify this, we can say 4, and 2 times 2 is equals to 4, plus 3 is equals to 28. So in the previous problem, I did take the sum of the two numbers and I multiplied it by the number outside the parentheses. So this time, let's solve it the other way. So let's say take the number 4 and multiply it by these two terms in the parentheses. So we can say 4 times 4, which because it's the first term, plus 4 times 3, because 3 is the second term, and this is equals to 28. So 4 times 4, that's equals to 16, plus 4 times 3 is equals to 12, which is equals to 28. And 16 plus 12, that is equals to 28. and 28 is equals to 28. And this is correct. So this just shows that no matter whether you decide to take the sum or the difference of the two numbers in the parentheses and then choose to multiply, or you decide to multiply the two terms individually, whichever way you choose, you'll still arrive at the same answer. So let's do one more example like this before we move to a word problem. So let's say 6 and in parentheses 2x minus 1 plus 4 is equals to 34. Okay, so again, we want to solve for the value of x. We have this term in parentheses. So we know that we have to multiply 6 by these two terms accordingly. So we can say 6 because it's the term outside the parentheses. 6 will multiply the first term, which is 2x. So we have 6 times 2x in parentheses. Then we have a minus sign, so we can write that down, minus. And then 6 will multiply the second term in the parentheses, which is 1. So we have 6 times 1. And then we have plus 4 is equals to 34. So simplifying this, we have 6 times 2x, and that's equals to 12x. So 12x minus 6 times 1 is equals to 6, plus 4 is equals to 34. And now we can collect like terms and have the variable on one side of the equation and the constants on the other side of the equation. So 12x, x is our variable, so we can have 12x on the left-hand side, and we have minus 6 plus 4. So we want both of these numbers on this side of the equation. We want them on this side. So let's start with minus 6. Minus 6 is a negative number. So when a negative number goes over the equals to sign, it becomes plus. It becomes a positive number. So it becomes plus 6. We can cross out negative 6 on this side. And then we have plus 4. When a positive number goes over the equals to sign, it becomes a negative number. So plus 4 over the equals to sign becomes minus 4. And we can also cross out this as well. So now we're left with 12x, and 12x is equals to 34 plus 6 minus 4. So 12x is equals to 34 plus 6 is equals to 40, and 40 minus 4 is equals to 36. So this is equals to 36. And now we can solve for x now. So to solve for x, we can divide both sides by 12. So 12 can cross out 12 on here. We're left with x. So x is equals to 36 divided by 12. That is equals to 3. So the value of x is equals to 3. That is our answer. So let's once again do a check to make sure we got the correct answer. So our former equation was 6, 2x minus 1 plus 4 is equals to 34. So we can plug in x into this equation. So 2 times 3, because we now know that x is equals to 3, minus 1 plus 4 is equals to 34. So we can simplify and say 6, and 2 in parentheses 3 means 2 times 3. So 2 times 3 is equals to 6 minus 1 here, plus 4 is equals to 34. Okay, and 6. And then we have 6 minus 1, and that's equals to 5. So we can have 5 in parentheses here. And then plus 4 is equals to 34. So 6 in parentheses 5, so 6 times 5, that is equals to 30, plus 4 is equals to 34. And 30 plus 4 is equals to 4, and 34 is equals to 34. So this is correct. Okay, so these were a couple of simple linear equations with using the distributive property to solve for the variable. So let's try a couple of word problems. So here we have the first word problem. It states that Emma is designing gift bags for a party. Each bag contains 3 small toys, and each toy costs X plus $2. So she makes 5 identical bags. The total cost for all the bags is $90. So we have to write and solve an equation to find the cost of each toy. So when it comes to word problems, like I say, the best thing is to always break down the problem and reread it carefully to know what the problem is asking us for. So the problem says that we should write and solve an equation for the cost of each toy. So let's go back to the question and see if the question ever explains that. So Emma is designing gift bags for a party. Each bag contains 3 small toys, and each toy costs X plus $2. So we can see here that the question tells us how much a toy costs. So let's write that down. We can say one toy is X plus $2. Okay, so we know the cost of one toy, and then the question tells us that a gift bag contains 3 small toys. So since we know the cost of one toy, let's find out the cost of 3 toys, which is equal to one gift bag. So 3 toys, 3 toys. So since one toy is equals to X plus $2, 3 toys be 3 times the cost. So 3 toys will be 3 times X plus $2. So this is the cost of 3 toys. And 3 toys can be found in one gift bag. So this one gift bag is also 3 times X plus $2. So we know the cost of one gift bag. So the question says that Emma makes 5 identical bags. So let me scroll down. We know that one gift bag is 3 times X plus $2. So if that's the cost of one gift bag, then 5 gift bags will be 5 times the cost of one gift bag. So we can say 5 times 3 in parentheses X plus $2. So now we know the cost of 5 gift bags. And then the question says that the cost of all the bags is $90. So we have to find the cost of each toy. So let me scroll down. So 5 gift bags is equals to 5 times 3 in parentheses X plus $2. And that's, oh, so 5, 3, X plus 2 is equals to $90 because that's the total cost of all the gift bags that Emma makes. So we have a linear equation here. So now we have to solve for x in this case. So we can simplify this. 5 times 3 is equals to 15. So we can say 15. And then we have x plus 2 in parentheses. And this is equals to 90. So now we have a linear equation where we can use the distributive property to solve for x. So we want to take 15, which is the number outside the parentheses, and multiply both of these terms in the parentheses by 15. So if we do that, we have 15, and the first term in the parentheses is x. So 15 will multiply x first, and then we have a plus sign, so plus, and then 15 multiplies the second term, which is 2. So 15 times 2. And this is equals to 90. So let's simplify. So 15 times x is 15x, and we have plus 15 times 2, that's equals to 30. So 15x plus 30 is equals to 90. So now we can solve for x using by collecting like terms. So 15x is x is the variable, so we want the constants on the other side. So we want plus 30 on the right-hand side. Positive number, when it goes over an equals to sign, becomes a negative. So this becomes minus 30. We can cross out plus 30 here. So we have 15x is equals to 90 minus 30. So 15x is equals to 60. So now we can solve for x by dividing both sides by 15. So 15x divided by 15 is equals to 60 divided by 15. So if we divide both sides by 15 here, we're left with x. So x is equals to 4. So now we know the value of x, but remember that the question asked us to find the cost of each toy. So if we scroll back up, we can see here that each toy cost x plus $2. So even though we know the value of x, we don't know the value of each toy, which is x plus 2. So that is a common mistake that some students may make. They may not solve the question properly. They may solve for x and think that's the final answer. But in this case, we have to find the value of x plus 2. So one toy, let's write it again, is equals to x plus $2. So now we know that x is equals to 4. So one toy is equals to 4 plus $2. So 4 plus 2, if we do that, is equals to $6. So one toy is equals to $6, and that is the final answer. So again, it's very important that we read the question because students can make common mistakes like that. So always make sure you know what the question is asking you for. So we found the cost of one toy, which is $6, but the value of x when we solved this out was equals to 4. Okay, so let's do one more problem relating to the distributive property. So here we have a second word problem. It says that Liam is buying notebooks and pens for school. Each notebook costs $3 and each pen costs $2. He decides to buy 4 sets, where each set includes 1 notebook and 2 pens. He spends a total of $52, including an extra $4 for tax and fees. So write and solve an equation to find the cost of one additional item Liam bought if its cost is represented by X. So let's break this down bit by bit so we can understand what the question is asking us for. So the question says that Liam is buying notebooks and pens. So since we're working with our notebooks and pens. Let's use letters to represent them. So we have notebooks, and let's use N to represent notebooks. So wherever we use N, just know we're referring to notebooks. And then we have pens. And let's use P to represent pens. So P, whenever we use P, we're referring to pens. Whenever we use N, we're referring to notebooks. So they say that each notebook costs $3 and each pen costs $2. So one N, because one notebook is equals to $3. And similarly, each pen, so one pen, one P is equals to $2. Okay, so the next part says that he decides to buy 4 sets, where each set, so one set includes one notebook and 2 pens. So let's simplify that. So one set is equals to one notebook and 2 pens. So that's the same as saying one notebook, so one N, and 2 pens. So we can say one N plus 2P, because N is notebook. So we're saying one notebook plus 2P because P is equals to pens. So we've written it as an algebraic expression. So this is one set. But the question says that Liam buys 4 sets. So if one set is equals to one N plus 2P, we can say 4 sets is equals to 4 times what one set is. So 4, and in parentheses, we have 1N plus 2P. So this is the cost of 4 sets. So the question says that he spends a total of $52, an additional, including a $4 fee for tax. So since we have looking at this equation, we have 4 and we have in parentheses 1N plus 2P. So we have 2 variables that we don't know the value of yet in this equation. But given the question that was given told us that one notebook is equals to $3 and one pen is equals to $2. So we know the value of one notebook and one pen, so we can substitute it into this equation here. So we can say 4, and one notebook is equals to $3. So we can say 1N is equals to 3. And then since one pen is equals to $2, then 2 pens will be equals to 2 times $2. So twice the cost. And 2 times 2, we'll write it out first. So 2 pens is equals to 2 times $2. So if we simplify that, we have 4 and then 3, and 2 times 2 is equals to 4. So we have 3 plus 4 on this side. So we can take the sum of the numbers in the parentheses, and 3 plus 4 is equals to 7. So we can say 4, and then the sum of the numbers is 7 in the parentheses. So we have 7, and 4 times 7 is equals to 28. So this is the cost of 4 sets, recall. So what we did was just simplify this equation, and we know that the cost of 4 sets is equals to $28. So let's go back to the question. The question says that he spends a total of $52, and he also has to pay $4 for tax and fees. So the question asks us to solve an equation to find the cost of one additional item that Liam bought if the cost is represented by X. So basically what it's saying is that this is the cost of 4 sets. 4 sets is equals to $28 here. But the question says that Liam spent $52 in total. So it means that Liam bought something extra to have spent $52. So Liam spent $28 on 4 sets of notebooks and pens. So let's write that down. He spent $28, I mean. The question also says that he had to pay an extra $4 for tax and fees. So he spent $28 on the 4 sets. He had to pay an extra $4 for tax. So that's 28 plus 4. And then now we know he bought another item. Let's scroll back up. Find the cost of an additional item Liam bought if its cost is represented by X. So Liam bought another mystery item that we don't know how much it costs. The question said that its cost is represented by X. So this mystery item is X dollars. So we can say 28 plus 4 plus this mystery item, which we refer to as X. And that the cost of all of this is equals to $52. Because the question here says that Liam spends a total of $52. So the total sum of all the things he bought, so 28 plus 4 plus X, the whole sum is equals to $52. So now we have to find the value of X. We need to find the value of this mystery item that Liam bought. So we can simply just move the variables to one side of the equation and have our constants on the other side of the equation. So X is our variable. X is what we need to find. So we can have X on the left-hand side. So we have two constants, 28 and 4. So we want both of those constants on this side of the equation. So 28 is a positive number because there's no sign in front of it, but when there's no sign, it means that it is a positive number. So this is a positive 28. So when plus 28 goes over to the right-hand side, it becomes negative 28 because it goes over the equals to sign. We can cross this out. And similarly, we have plus 4. When plus 4 goes over the equals to sign, it becomes a minus 4. And we can also cross this out. So we're left with X. X is equals to, we now have 52 minus 28 minus 4. So now we can simplify and find the value of X. So X is equals to 52 minus 28. So let me quickly punch that into a calculator and solve. So 52 minus 28, that is equals to 24. And 24 minus 4 is equals to 20. So X is equals to 20. So this is the cost of Liam's mystery item. So this is the value of the item that Liam bought for X dollars. So let me go up. Said we should write and solve an equation to find the cost of one additional item Liam bought if its cost is represented by X. So now we know that X is equals to 20. So that is the cost of the additional item that Liam bought, which is $20. Okay, so those were a few problems that involved solving linear equations with the distributive property. I do believe this last question was it required a bit more critical thinking that we usually like used in the previous questions because we had two variables. We had notebooks and pens, but we were also given the value of n and p, so that made it easier. But I do agree that this problem was a step up from the previous questions that we were only working with one variable. This one had us work with two, but we were given the value of those two variables. So we just had to find a way to understand the question, plug in the right values, and then understand what the question was asking us for. So uh, I do hope that these questions helped in understanding distributive property. Again, like I always say, it's important to practice. I can find some word problems like this or this previous one. Just take time to read through the question, understand what the question is asking you for. You can underline important details, and then you can also uh write break down the question bit by bit and solve it accordingly bit by bit so you can be able to have information to work with when solving the final question. So uh I hope that these questions helped you understand the distributive property better. And thank you so much for watching this short video.